Evaluating functions. Function notation. There are numerous ways to represent a function, including set notation, a map, a graph, a table, or an equation that relates the variables x and y. Function notation is as follows. For a function named f, the notation f of x is the value assigned to the input x. The letter f names a process, an input-output device, that assigns to each allowable input x an output or a y value. So if you put a value in here for x, you will get out a y value, or f of x output. So in this example, we're given that f is a function that is a set of ordered pairs. Evaluate f of 1. So that means that the x value is 1, and we want to know what the y value is associated with 1. So when you put in 1 into the x value in this function, you get 2 as a result. Alright, when you put in 2 as an x value into this function, 2 as the x value, you get 4 as the output. Which input x produces the output of 6? So if you want the output 6, you would put in an x value of 3. Alright, here's another example. So given a function map, evaluate f of 0. So what that means is 0 is the x value here. So if you put 0 into this function, what do you get out of it? You get -1. Alright, and if you put 3 into here, you get an output value of 0. Here's an equation example. Given the function defined by f of x equals 3x plus 2, evaluate f of -1. Alright, so all we do is plug -1 into this spot. So you put -1. So what you do then is just wherever you see an x over here, you replace that with -1. So 3 times -1 is -3 plus 2, and that is -1. So that's all you do. It's kind of like a little machine. You plug in your x into the box, and then you just replace all of the x's in the equation with whatever value you've plugged into it. So if we're going to evaluate f of 3, I'll write it again down here. So f of 3, so we have 3, see we're using this equation here, 3, so then we plug in 3 for x, and then you just finish whatever's up here, plus 2. So f of 3 equals 3 times 3 plus 2. So this is 9 plus 2 equals 11. Alright, so let's do some more practice with the equations. Let's evaluate these values plugged into this function. So for f of 2, all we have to do is plug 2 into that equation. So we have 4, and then see there's an x here now, so we just put 2, and then we finish plus 1, and so then f of 2 equals 4 times 2 plus 1, so that's 8 plus 1 is 9. Alright, let's do a different color. Alright, so that one equals 9. Alright, let's do red next. F of 5. So we start with our equation up here, 4 times x, and in this case x is 5, plus 1. You just finish that. So then we have f of 5 equals 4 times 5 plus 1. So that's 20 1. Okay, let's do purple. F of negative 2. That's more of a blue, but oh well. All right, f of negative 2. We have 4 times negative 2 plus 1. So f of negative 2 equals 4 times negative 2 plus 1. That's negative 8 plus 1 equals negative 7. All right, and then finally, we have f of 0. That's purple. All right, f of 0. So we start with our equation. 4 times x, which is 0, plus 1. And we have f of 0 equals, this is 0 plus 1 equals 1. Solving for input. To solve for input means to find all of the x values that produce a given output y. Set notation example. All right, given f is a set of points, what we're going to do is move backwards. So solve for x. F of x equals 1. So if the y output value is 1, all we do is go and look to see where the y values are 1. And in this case, it's here. So the answer, the x we're looking for, is also 1. Solve for x. F of x equals 4. All right, so the y output value is 4. So let's look in our points. Here, the y value is 4. So the x value that gave us 4 is 2. All right, solve for x. F of x equals 9. So the y output value is 9. Here we see 9. The x value that gave us that 9 is 3. So 3. Here's another example using mapping. All right, so solve for x. G of x equals negative 2. So the output value is negative 2. So we go here and we see negative 2 is here. And what input value gave us negative 2? Negative 1. So that's negative 1. Solve for x. G of x equals 0. So if the output value is 0, here's our output values. There's 0. Which x input value gave us 0? That is 3. Solve for x means to find the inputs. So we're kind of just moving backwards from what we were doing before. Now we're given the outputs and we just need to find the inputs. To solve for input means to find all of the x values that produce a given output y. All right, so given the graph of f, we're going to solve for x. The output value we want is 9. So all we do is we see the y value of 9 and see where it intersects the graph. It intersects right here. This coordinate is 1, 9. So the x value that gave us 9 is 1. All right, solve for x. F of x equals 5. That means the output y value is 5. So on our graph we see 5. Oh, and here we see it intersects in 2 different points. This point is negative 1, 5. This point is 1, 2, 3, 5. So there's 2 answers. The x input of negative 1 and 3 will both work. They would both give you a y output of 5. All right, and finally, if we want the y output to be 0, we see here's 0. We see it also intersects twice. The coordinates of these 2 points are negative 2, 0, and this is 1, 2, 3, 4, 0. So for y outputs of 0, we have x inputs of negative 2 and 4. Okay, In this example, this is an equation example. Consider the function h given by h of x equals 5 plus 3x. Solve for x. H of x equals 17. All right, so we know that the answer is 17. 17 is the output. 5 plus 3x is the rule. So we're going to set the rule equal to the output, and then we just solve. So we just set this here equals to 17, and then we solve for x. So the first one is done for us. 5 plus 3x equals 17. You move the 5 over there and divide by 3, and you get x equals 4. So let's do the next one. H of x equals negative 10. So all we do is set the rule equals to the output. So the rule is still 5 plus 3x, and then we're going to set it equal to negative 10. All right, and then we just solve for x. So 3x equals, we're going to subtract 5 from both sides, and then we're going to divide both sides by 3. We see that x equals negative 5. So x is negative 5 for this one. All right, and then I'm just going to delete this. All right, for this one, we are going to first have to amend the rule because this is no longer h of x. We're now going to input a different value in, and then we'll do this next step. So first, let's rewrite the function h of x. 5 plus 3x. Next, we're going to input this value in for x. All right, and then we're just going to solve for that. So 5 plus 3 times 2x is 6x plus, distribute this, 3. So 5 plus 3 is 8 plus 6x. So now this is our new rule. So then we continue the way we were before. We're going to put our new rule equal to our output. So let's rewrite this down here. 8 plus 6x equals our output, which in this case is 5. And then let's just solve this. So 6x equals, we're going to subtract 8 from both sides. Divide both sides by 6. We get that x equals negative 1/2.